All right, so today's video is a quick one on natural selection on polygenetic traits. Okay, so once again, natural selection, obviously, nature is causing a change in the population due to some effect. Okay, we'll look at that effect here in a second. Polygenetic, poly meaning many, and obviously genetic meaning traits, obviously. So we look back at Darwin's finches for our example for polygenetic traits. Remember in class we talked about Darwin studied finches and he had like different beak sizes. There was a big beak for use for breaking up nuts and large seeds. The small beak, it was kind of like the catch-all. It could do small seeds, but it couldn't do the big seeds. It couldn't do tiny bugs, but it could do medium-sized bugs. But it was kind of the catch-all. It was in the middle. And then we had the tiny beak. Obviously, the tiny beak could not open up seeds, could not open any type of nuts, but could eat insects. Okay, so right here we have a polygenetic scenario. We have three traits set up. So typically when they give this question to you on a graduation test, it's always a graph. Okay, it's going to be a graph because they have to show you how it's moving. And basically what they're wanting for you to describe is what type of directional selection is it, or what type of selection is this happening. And there's three types of selection when you look at natural selection on polygenetic traits. Now keep in mind, this is on polygenetic traits. This is traits that have multiple. So we have three beak sizes. That's obviously multiple. If we were just looking at one thing, this would not apply. So poly, has to be dealing with many things. So we look here at our graph, we see we have the beak size over bird population. Okay, and the T stands for tiny, S stands for small, and B stands for big, just like we have up here. So you see here in our original population that most of our birds are favored in the tiny to small beak range, okay? And we have very few population in the big beak range, okay? So what happens in a directional selection is when individuals of one end of the curve have a better fitness, okay? And so here is what typically will happen. You have a population like this starting off, and something's going to happen. Because remember, natural selection is going to drive change. And so it could be essentially where, I don't know, a predator moves in, a food source dies off, but what you're going to do is you're going to cause a shift in this graph. So what's going to happen is now this green line that I'm about to draw, this green line is going to show a directional shift. So you see how we've shifted away now? It's directional. It was over here favoring the small to tiny beak birds, but now something happened in the environment which caused the population to shift in a direction. That's how you get the name directional shift. It shifts in a direction, and now it is favoring more of the birds that are from small to big. So that is a directional shift. It pushes the bird population one way, or whatever the population you're studying. All right, the next two, stabilizing selection. Okay, same scenario. We have tiny beak, small beak, big beak. And stabilizing is when individuals at the center of the curve have a better fitness. So essentially, here's your original population. Something changes, and it looks something like this. You're going to see a drastic increase in the center. Okay, and so this increase in the center is telling you that it's going to be stabilizing. So individuals at the center of the curve have the better fitness. So whenever you see a change like this on a graph on your test question, this is showing you that this is a stabilizing selection, which is telling you that the tiny beaks and the big beaks, there's something going on with them and they're dying off. Okay, something has changed. Maybe their food source, maybe there was a disease or something like that. Okay, so that is what it is telling you down there. All right. And lastly, disruptive selection. Once again, you start with the original population, tiny, small, and big. And this is individuals at the ends of the curve will have a better fitness. So you have the starting off population, and then something happens. Once again, it could be a die off of food or source. Okay. And so what happens is you see this happening. The ends will be favored. All right. Now you see here, now these are the peaks. Okay. The tiny beaks and the big beaks are more selected for, and now you see here that the beaks in the middle, the small beaks are selected against. So this is called a disruptive selection when the ends are favored. All right. All right, these typically show up in a graph, like I said, on a graduation test. You just need to be familiar with what it looks like. So if you see two peaks at the very end like this, that's disruptive. If you see a giant peak in the middle that is showing that is favoring the middle, that is called a stabilizing selection. If you see a shift, so see how we went from here to over to this shift, that's called a directional selection, okay? You really just need to know the names of them. I've only seen one question on the graduation test about these in the past, but I want to make sure you were familiar with them. All right, just know those three definitions and know what the graphs look like, and that's all I would know for the test. Thanks.